They're a bunch of mean old cranky ladies. No, they're really not.
Yeah, they're a bunch of mean old cranky men.
Always guys.
It's always guys. Okay, so first off, summation, right? The symbol for summation is this funny looking E. It's a sigma, uppercase sigma, okay? So the way that this would be represented, we'd say something like K equals 1. Let's just say K equals 1 to 3. Of X to the K. Okay. So this means that we start with K at 1. So it'd be X to the 1. And then we add, because this is a summation, so that means we're adding, right? So then we add the next one. After we do K equals 1, the next one would be K equals 2. So it'd be X to the second. And then the next one would be X to the third. That would be the summation of K equals 1 to 3 of X to the K power of K. Okay? Okay. Okay. Thank you, Carson. If we had K equals 1 to 4 of 2 to the K, right? That's going to be 2 to the first plus 2 to the second plus 2 to the third plus 2 to the fourth, which is 2 plus 4 plus 8 plus 16. So let's see, that's going to be 14 plus 16, so that will be 30. Okay? That's what summation is. Of course, it gets harder, right? We could have something like the summation of K equals 1 to 5 of X squared plus KX plus 2. Okay, so there we're changing the K value. So this will be X squared plus X plus 2 plus X squared plus 2X plus 2 and so on, okay? And you would add them together. So if you think about Riemann sums, right, Riemann sum, you're looking at, right, a bunch of rectangles, and we are adding the area of each rectangle, right? And we talked about the idea with Riemann sum is the more rectangles you have, the more accurate that sum or that area under the rectangle. So a summation lends itself very well to representing that Riemann sum. And of course, as this number up here increases, that summation becomes a better estimation of the area under that curve. Does that make sense? Okay, so what we're going to do today is we're going to kind of take a little sidestep and just look at those summations for a little bit, mainly going from summation to integral notation and going from integral notation to the summation notation. Remember, the Riemann sum is estimating the integral, and the integral stands for the area under the curve, okay? So I'm going to actually switch over. There's a resource that we used last year and that I use quite a bit just as a review packet for your AP exam, but her name is Krista King. She does a really good job of explaining this part. So I'm going to kind of play that video and then we'll look at some together and go from there, okay? So that means I need to switch it back over. Let's see again. And here. Okay. Oh, I have to switch it here. Duh. Okay. And pause this video because there's nothing to record. And we're looking at section 6.2. We're looking at 6.2. There we go, right there. Okay. I'm going to run down here. Yeah, I actually don't like the way that I don't like the way that our notes or our textbook explains this section. So that's one of the reasons that I wanted to look at Christy King. Okay, so just as a reminder, okay, this is what we just did, writing our integral notation as a summation. Okay, and in order to do that, we need to know that delta x, right, because we've got a delta x in our summation, right? Delta x, by the way, delta x translates to dx also, right? Delta x is our b minus a over n. And then x sub I, that's a plus, did I do that right? Yes. A plus delta x I. Okay. Okay, so let me see if is I and K the same thing. Yes. Yes. Okay, so we look at an example up here. I think it's the same example actually that she did. Okay, so example 3, we've got y equals the square root of x. Let's go ahead. I'm going to work through that again with you, putting it into summation notation. Okay, so this particular problem, right, they're going from 1 to 4, and the function is square root of x. So the integral notation would be a to b, so that's 1 to 4 of f of x, so that's the square root of x dx. That would be the integral notation. Okay? Let's put that into summation notation. Right? So first we have to figure out what delta x is. So delta x is b minus a. So what's that? 4 minus 1 over n. Because in this particular example that I'm talking through, forget about what they did here, okay? For now, we're saying we don't know how many intervals. So this is 3 over n. Okay. So now I have to figure out what x sub I is, because remember, my formula says the integral from a to b of f of x dx is equal to the limit as as n approaches infinity of the summation from I equals 1 to n of f of, make sure I get the right same notation that they used, f of xi delta x. Okay, so we are trying to go to this form from the integral form. So we need to know what x sub I equals. X sub I is a plus delta x I. Well, that means we have a, what's a? 1 plus delta x, which is 3 over n I. Now, if I want to know f of xi, then every place I see an x in the original f of x equation up here, I put x sub I. So f of x sub I is going to be the square root of, instead of x, it'll be the square root of 1 plus 3 over n I. So I have my f of xi and I have my delta x. Now I can write it in the summation form. So the integral, write that in a place that you can see it. Okay, I'm going to write it over here. The integral from 1 to 4 of the square root of x dx is equal to the limit as n approaches infinity of the summation from I equals 1 to n. We don't know how many subintervals there are, so we leave it as n. And then we do f of xi, so the square root of 1 plus 3 over ni times delta x, which is 3 over n. And that's it. Yes.
Do you have to write it with the brackets like that in order to be like correct, or can you just do the f of and then put that, or not like f of, but just,
No. Say that again.
like, do you have to put the brackets around it for it to be correct? Like, is that correct notation, or can you just put like?
So you could write it as 3 over n square root of 1 plus 3 over ni. You could write it like that. Okay. Also, sorry, it's messy on the notes here. We're taking the limit as n approaches infinity, right? So this summation, so if I were to do this summation, I would plug in the 1 plus, and I plug in the next number 2 plus, and the next number 3. Every single time I've got this 3 over n. So one of the properties of summation says that we can actually bring that number out. That's actually a constant. 3 over n is a constant. We could actually bring that number outside like that. And then we're looking at 1 plus 3 over ni. So do the summation and then multiply it all by 3 over n. Since each individual term is being multiplied by 3 over n and add it together, I could add them all together first and then multiply it all by 3 over n. So you could write it like this. I normally wouldn't even fuss telling you that because you're going to get the same place doing that. But sometimes you'll see your multiple choice questions on your AP exam will be like that. Yes.
So you never, in this situation, you don't know what n is?
Correct.
So it'll always just stay n?
Right.
Okay. And
Yep.
what does n represent again?
N represents the number of subintervals, number of rectangles.
Oh, okay.
Okay. Let me just pause and see if I can find.
What n equals.
I know. Well, that's why I say. That's why I crossed it out. I said ignore that because we're just. This was just their way of introducing the topic. Okay. Let me see if I can find a couple more examples. They do a. I feel like they do a pretty poor job. This one, okay. Okay, let's just work with these and see if we can do these separately, okay? Okay, so let's put these into summation notation, okay? I'm down here on page 10. So first, right, what's our formula look like? We're looking at the limit as n approaches infinity of the summation of I equals 1 to n of f of xi delta x. I like to write the formula out because then I remember what parts I need to figure out, right? So it just reminds me that I need to find f of xi and I need to find delta x. Yes.
Will it ever tell you like I is the width, right? Or the
I is each rectangle. So n refers to the number of rectangles, right? So when I equals 1, that's the first rectangle. When I equals 2, that's the second rectangle. Right. So how do I find delta x?
you take the difference of the interval over.
Right. Remember, our integral goes from a to b. It's always the smallest number to the largest. So this is going to be 4 minus 2 over n. So that's 2 over n. So delta x is 2 over n. X sub I, okay, so x sub I will be a, which is 2, plus delta x, 2 over n I. Okay. So we're looking at the limit as n approaches infinity of the summation I equals 1 to n. By the way, your notes uses k, but we're using I, right? Okay, so we need f of xi. So I like to actually, up here, I like to write f of xi separately before I plug it in. So here's my xi. So every place I see x in the original f of x, I'm going to plug in this. Okay, so this is 3 times 2 plus 2 over ni squared minus 1. Okay, let me just remind you, the integral is written in the form of the integral from a to b of f of x dx. That's how our integral is written. Okay, so that's a pretty complicated f of xi, but that's okay. All right, so I've got, here I'm going to use the brackets really because it is a pretty complex looking expression. So I've got f of xi, so that's 3 times 2 plus 2 over ni squared minus 1. There's my f of xi times delta x, which is 2 over n. And that's it. Okay. Try letter B by yourself. Okay, so let's see here. What do we have to do first? Right. Delta x is b minus a over n. So we have 0 minus negative 2 over n. which gives me 2 over n. There's my delta x. Okay, Nikki, what's the next thing? Yeah, x sub I, which is a plus delta x I. All right, so that gives me a, what's a? Negative 2 plus 2 over n I. Okay. Let's see here. Grace, what now?
You find f of x of I.
Yeah, f of xi, right. So let's see, f of x, we can see from this is x plus 3 squared. So f of xi, so we're going to do negative 2 plus 2 over ni, oops, right, plus 3 squared, which we can rewrite as 2 over ni plus 1 squared. Yes.
Would it be like, I guess, proper to write the negative 2 plus 2 over ni in parentheses and then plus 3 and then another set of parentheses squared?
Yes. But it really makes sense to kind of do that negative 2 plus 3 and simplify that. Right?
Okay.
Okay, so we're looking at the limit. A lot of times I forget the limit part. Don't forget that. It's very important. The limit as n approaches infinity, the summation of I equals 1 to n of f of x. Let me write it over here. Of f of xi times delta x, all right? So we're looking at 2 over ni plus 1 squared times 2 over n. We're finished. Okay?
What does it mean when it says value? Does it mean it wants it for every, like, from the integral? Like,
So it wants you to actually evaluate this going from negative 2 to 0.
Yeah.
So,
Plug it in.
right, you can't really do that in your summation form. You have to know how to do it from the integral, which we haven't actually talked about yet. Well, we have in the extra session, but not in class. Okay. Yes.
Why do we keep n there instead of putting something else?
Because at this point, we don't know how many subintervals. Okay. Okay, the last one. So this one's different because it's a trig function. So again, we're looking at the limit as n approaches infinity. The summation of I equals 1 to n. F of xi delta x. Okay. So don't let that summation that trig function scare you. Right? In this case, f of x is equal to sine x. So we've got delta x equals b minus a over n, which is pi minus 0 over n, or just pi over n. So that's my delta x. X sub I is a plus delta xi, which would be 0 plus pi over ni. So we're just looking at pi over ni. There's my delta x. So f of xi, that's going to be sine of pi over ni. Right? Okay, so we're looking at the limit as n approaches infinity of the summation from I equals 1 to n of sine pi over ni times pi over n. Okay. Okay, what I would like you to try tonight by yourself, I would like you to try to translate this back to the integral notation, so go backwards. I find this to be much harder. Okay, so your homework tonight is to just see what you can work through with that, right? Because if you look at this right away, we know this is my delta x. So what does b minus a equal? B minus a over n equals, right, so b minus a is 5, right? So that's how you're going to work. You're going to work backwards. We want to get it in the form of integral from a to b, f of x dx. So you got to figure out what a and b are, and you've got to figure out what f of x actually is. Okay? Yes. Okay. Yeah. Almost. Your a and b are wrong.